All right, so we are going to look at a concept of casting. So on the screen, you have our shell window, and we have a casting program over here where I've created three variables, x, y, and z, that all have a similar value but a very different value. So x here is storing the number 17, y is storing the number 17.0, and z is storing quote 17.0. So even though they're storing more or less the same thing, these are three distinct different types. Now, in some programming languages like Java or C++, variables need to be given their type ahead of time. So, for example, in Java, I would say x is an int, y is a double, and z in this case would be a string. Uh, but in Python, a convenience is that the language determines the type based on the value being assigned. Now, the downside about that convenience is a program might not always behave the way that we think it's going to if we're not sure about what information it's storing. So we have these three values. Below, we're just printing each one. So print the text x is, and then also the value for x, value for y, value for z. So let's just save this, run it, and just take a look at what comes out. And you see we got 17, 17.0, and 17.0. And when you see it printed, these two look, y and z look indistinguishable from one another. Let's try doing something else. Why don't we say, let's print y, let's do y plus y, and z plus z, and x plus x. So we might expect to get 36 or 35, 34, 34 sorry, 34, 34, 34. Let's see what we get. Run it. We get 17 plus 17 is 34, so we get that. 17.0 plus 17.0 is 34.0. We get that. But then the third one, 17.017.0, because here we are dealing with string types. And string types, when they use the plus operator, concatenate, meaning they add to the back of and they just keep continuing. Whereas this is a float type and this is an int type, and they use the plus sign as you would in a math class, adding the values together. So let's go back to where we started, where it's just x, y, and z. And one thing that you can do when you're not sure about the type of information being stored is simply to ask the variable. So we're going to say, what is the type of x? What is the type of y? And what is the type of z? So this built-in method will just tell us what Python has decided these three things are. So we'll save again, we'll run again, and we see that x is a class of type int, storing an integer value. Y is a class float, storing a decimal value. And z is of class str, which stands for string, which means text, a line of text. So now that we know those types, we might say, well, I actually want to treat these a little bit differently. So perhaps I like the precision of a decimal. So I don't want to just say that I'm 17. I want to say 17.0. There's no tenths of a value, just 17 flat. Well, I can say treat x like it's a float. It's called casting. So I'm going to say, even though this is an integer, treat it like it's a float. Likewise, I might say for y, treat it like an int. And if I do that and save and run, you'll notice that now the position of the 17 to 17.0 has changed, because whereas this was a different type. In this case, we had an int and a float. They did store the same value. They're both storing the value of 17. But when I display a value of 17 as an integer, it gets displayed as 17. When I display it as a float, it gives me that first decimal just to indicate that it's a float. Now, what if I were to say, treat z like a float? So try to cast it. Instead of treating it like text, treat it like a float. Let's see what happens. Save and run. It doesn't look like anything changed, but if we were to try to add these together now, remember before it said 717.017.0. Now if I were to add these together, save and run, I'm going to get that answer 34. So I've now said even though Z is holding 17.0, for the purpose of what I'm doing in this line, treat it like a float and allow it to add. Now let's see what happens if I say treat it like an int. Let's see if I can do that. So instead of casting it to a float, I'm going to cast it to an int, and let's see what happens. I get an error here. All right, so the problem is I can take a float and treat it like an int. I can take an int and treat it like a float. But in this case, converting a string to an int can only be done if that string is already, in fact, an integer. So I change this to 17 and run it again. I no longer get that error. Likewise, if I try to treat Z like a float now, and let's see, save and run, it can do the conversion. So I can go backwards. I can go from a int to a float easier than I can go from a float to an int. So casting is not always super straightforward. You can say treat my integer like a double or like a floating value. That's not so hard. But you can't say treat my integer like a car and ask it to drive. We can't just cast anything to be anything else. There are some changes that we can accommodate and others that we cannot. So that is a brief overview of casting and using the three most basic types that we're going to deal with: ints, floats, and strings. All right, bye now.